Hello, today we are going to do a read about vectors. Okay, so vectors basically build up the basics of physics, and it is really important that we understand what vectors are before proceeding to further more complicated subjects and topics in physics. Alright, so vector is a purely physical quantity which is defined as an arrow with direction and a specific length. So vector is basically any quantity which has two components, a magnitude and a direction. If a quantity has these two, we say it's a vector. Alright, now when we talk about what vector quantities, we include some physical quantities like force, like velocity, like displacement, and so on. All of these are vectors because force only makes sense when we have a direction assigned to it. Velocity only makes sense when we have a speed, that is the magnitude, and a direction, which by definition of a velocity it has to have a direction, so it only makes sense if it has a direction, and so does displacement. So these are all vector quantities, and we use vectors to define them and so that they make full sense of their individual meanings. Vectors are represented, as I already said, by an arrow, and an arrow with the length that is specified gives us the magnitude. The direction of the arrow points to us the direction in which the vector is oriented along. For example, if a body is kept on a table and we apply a force in this direction, so this, my friends, is a vector, and the vector is represented in this manner: the head pointing towards the direction, and this specific length gives us the magnitude of force. Okay, so this was about vectors. There is another quantity which is very widely used in physics, which is a bit different quantity but has a common meaning with vectors, and it is a scalar. A scalar is a physical quantity that only has a magnitude and nothing else. Now, it really does not require a direction assigned to the quantity in order for it to make proper sense. For example, temperature. We really don't say the temperature in the northeast direction is 35 degrees Celsius. Well, that does not really make sense. It's additional information adding the direction. Also, it does not really make sense. So we avoid any direction notation to a scalar. And that is why on this basis it differs from vectors. So, for example, pressure. Now, pressure is yet another quantity which only requires a magnitude to specify its meaning, and that is all that it requires. It does not require a direction. However, the force that this pressure generates is only specific and is only meaningful when we have direction assigned to it. So the force can be turned into pressure, or in other words, a vector is turned into a scalar, but they both individually are different quantities, different physical quantities. Alright, so this is how we define a vector. Now, there are certain rules in physics which make a lot of sense, and they are actually rather useful for physicists. For example, addition of vectors. When we have to add two vectors, say vector A and vector B, we arrange them such that the endpoint of another vector is lying on top of the arrowhead of the initial vector, and these 2 points will correspond to the resultant vector, which I denote as C. So I can write, this actually means that A vector plus B vector gives us a C vector, and which is defined in this manner. So this is the diagrammatic representation of a resultant, and this is how we write it in text. This is vector addition. Now if I have to talk about subtraction, well, for that I need to understand that if I have a vector, say B vector, now another person asks me what would be minus B vector. Now minus B vector by definition is a vector whose magnitude was the same as B vector, but the direction points in the reverse direction as of the initial B vector. So if this happens, and this is how B vector is defined, minus B vector is defined, I can say A minus B vector would be equal to A added to negative B vector, which could be another vector, or this picture turns into this picture, and this makes the difference vector, this makes the resultant vector. Remember, resultant vector is equal to A vector plus B vector, whereas the difference vector is equal to A vector minus B vector. And this is how they're represented. So you can see they are different in both magnitude as well as the directions, and hence they are completely different vectors. But they can be defined only by changing the orientation of B. They can be diagrammatically represented also in a similar manner.